This lesson goes with section 3.5 in your algebra text. Here's a problem that we might use the math in this section to solve. I ask you to predict how many mistakes Mrs. Dever will make during the school year. You know you track my mistakes in class, and we're trying to figure out how many I'm going to make during the entire year. So here's some information. We've been in school for 3 full weeks, about the time you're listening to this presentation. There are 36 weeks in a school year. And as of the time that I'm recording this, there are 13 mistakes on my mistake list. So see if you can make a prediction about how many mistakes I'll make during the full school year. Once you've made your prediction, you can resume this presentation. All right, so one way to solve this problem is to assume that I'm going to keep making mistakes at the same rate all year long. So if I were to find a unit rate of mistakes per week, that would stay constant throughout the year. So if I've made 13 mistakes in the first 3 weeks, you can expect I'd make a total of 26 mistakes in the first 6 weeks. And we're wondering how many mistakes in a total of 30 weeks, because that 36 weeks, that is equivalent to a full school year. If my mistake rate stays constant, then it means I make 4.3 repeating mistakes per week, whether it's over 3 weeks or 6 weeks or 36 weeks. We're going to assume that rate stays constant. Oh, hey look, there's random trivia, even in your at-home lessons. Check this out. Do you know all the members of the Black Eyed Peas? Here they are. Will I Am, who we now know is William, Fergie, Taboo, and Apple Diep. Back to math, setting up a proportion. We're going to use a proportion to solve the problem about how many mistakes I'm going to make in the year. The hardest part of proportions is setting them up correctly. What's important to notice is that our two ratios both have the same units on the top. So in this case, we both have mistakes on the top and the same units on the bottom, weeks on the bottom. One ratio is what I'm going to call the short-term ratio. So that's like the number of mistakes on the top and the number of weeks in the bottom in a 3-week period. And the other one is the long-term ratio. This is the full year one. So I don't know how many mistakes go in the top, but I know 36 weeks go in the bottom. To solve this proportion, one thing that we can do is we can apply the properties of equality. So I'm trying to get the x here by itself. I notice that on the right-hand side, x is divided by 36. To undo the dividing by 36, I'm going to multiply by 36. And when I do that, on the right-hand side, I have to do the same thing on the left-hand side. The 36's, they're on the top and the bottom of that fraction bar. They represent one of those ones in disguise. 36 over 36 is just 1, so I don't need to write it in there because this is really x times 1. So I have x equals 36 times 13/3. When I'm multiplying fractions, it's easiest for me to write both numbers as ratios, so 36 over 1 times 13 over 3, and then we multiply our numerators together and we multiply our denominators together. 36 times 13 over 3 is going to give us our x. Let's look at another way that we can do this. So on the left, we were simply applying the properties of equality and simplifying for x. Another option is to use cross products. Whenever we have a proportion that is two ratios that are equal to each other, we can set their cross products equal to each other. So the first cross product is going to be 3 times x, that's 3x. The second cross product is going to be 13 times 36, that's here, and we set those two cross products equal to each other. Now this looks pretty darn different than what we did on the left. We know the steps on the left are justified by the properties of equality. What I'd like you to see is that the steps on the right are in fact just shortcuts for applying the properties of equality. So now on the right, to get x all by itself, I'm going to have to divide both sides by 3. And on the left-hand side now, the 3 on the top and the 3 on the bottom cancel out because 3 over 3 is just 1, and 1 times x is just x. And so I end up with x equals 36 times 13 over 3. Applying the cross products really is the same as multiplying both sides of the equation by both of the denominators. It's simply applying the properties the division property of equality twice. It's a nice convenient shortcut, but it does still follow the properties we've learned.